So far, we've looked at the fundamental counting principle and the concepts of factorial and permutations. And in all of these, the distinct nature of the original set of objects and the group being selected has been stressed. So by distinct, when I say that, I mean different. We're now going to explore when ordering is unimportant. In these cases, we are only interested in what is being selected and not the order of it being selected. So unlike our example before with the order that performers were going in a talent show, in this case, it doesn't matter what order things are happening in. We call these selections combinations, and we're going to actually explore an example of combinations, and we're going to compare it first by looking at a situation that is a permutation first. So let's suppose that we have four individuals running for the office of president, vice president, and secretary of a student council. So this situation would be a permutation because the order matters. Somebody would be president, somebody would be vice president, and somebody would be secretary. And those positions are different and they're distinct, so the order would matter. So that situation, we would say that's four people and we're permuting them over three offices. Based on our previous video, we saw that this formula would be 4 factorial over 4 minus 3 factorial, which would be 4 factorial over 1, and 4 factorial over 1 factorial technically, but 1 factorial is 1, gives us 24 over 1. So there are 24 different arrangements of our permutations of how individuals could be selected for these different roles of president, vice president, and secretary. So then we can use the letters A, B, C, and D to represent the people or the individuals that we are choosing for the first position for each position. And then we'll say that the order tells us what role they would have in these different permutations. So if the letter is in the first position, then that's representing them being president. And if the letter's in the second position, that's representing that person being vice president. And if it's in the third position, that's the person being selected as secretary. So we can put names to it if you want. We can have Anna, Brenda, Carlos, and Debbie. Okay. My name is Anna. I get excited when I get to use it. But we're just going to use the letters to represent it. So we're going to identify all the permutations. So let's just start with, let's say Anna is selected president, and then we could have Brenda as vice president and Carlos as secretary. Or we could have Anna as president, Brenda as vice president, and Debbie as secretary. Or we could have Anna as president, Carlos as vice president, and Debbie as secretary. We could also have Anna as president, Carlos as vice president, and Brenda as secretary. And we could also have Anna as president, Debbie as vice president, Brenda as secretary, and then we could also have Anna as president, Debbie as vice president, and Carlos as secretary. So that's just all the situations where Anna ends up president. But we could also have a situation where Brenda ends up president. And we can write out all the different possibilities for this. I'm going to pause myself and write them all out. I suggest that you do the same, write them all out, and then just compare. And I suggest doing this very methodically so that you start with Brenda, Anna, Carlos, Brenda, Anna, Debbie, and so forth, so on. Do it very methodically so that you don't leave anything out. And we already know how many there are supposed to be because we saw that there should be 24 permutations. So go ahead and pause, and then when you're done, check with my list. So you should see a list of 24 possibilities. There's 6 options for each person being president, with the other people being in other roles. And so we have this list. Now, when we think about combinations, we don't care about the order. So that would be like taking this situation and saying, okay, well, instead of people being assigned roles, specific roles, let's say we had a club and we had 4 members in the club and we needed to pick 3 of them to represent the club for like student government association. So at TCC, we have a student government association on the Northeast campus, and club members pick 3 people to represent their club. So it doesn't matter. They're the same role. They're just a person who's representing the club. So the order doesn't matter. So anytime we don't have order mattering, we're talking about combinations. But let's look and see what happens here. So here's how we're going to address this situation. We're going to look at the permutations we just listed, okay? And we're going to find all the permutations which use the letters A, B, and C. And we're going to let's put a blue box around them. So we have A, B, and C right here, A, B, and C right here, A, B, and C right here, and we are going to keep going until we find everything that has A, B, and C, no matter the order. So, okay. This shows us that if our situation, the order doesn't matter, all 3 are just showing up as representatives, they don't have a specific role in the order counts, and being president is different from being vice president. If they're all on the same level, nothing is different about the situation, then having Anna, Brenda, Carlos is the same thing as having Anna, Carlos, Brenda be the representatives. So we wouldn't count those for a combination. So these all represent, these blue boxed, those or triplets represent one combination. So let's find another set of permutations that contain the same 3 letters. So let's actually start looking at ABD. So I'm going to do the same thing and box anything that has ABD. ABD. And I'm going to box those in yellow. ABD. ABD. And there are 1, 2, 3, 4, 5, 6 of those. And again, those all represent the same situation, and they represent one combination. We're going to keep going. Let's do ACD now. ACD, 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 ACD. Awesome. And let's do one more to find the last ones, which are our BCDs. I'm going to circle our boxes in purple. These all represent, these color-coded trios represent the same combination. How many different combinations do we have? Well, the blue ones is 1, then we have the yellow, 2, then we have the green, and then we have the purple. So this represents 4 combinations. So we're going to use this to figure out the formula for combinations. So let's think about what we started with. We started with 4 permute 3, which gave us 24. But then what do we have to divide 24 by to get 4 combinations? So 24 divided by what gives me the number of combinations that we got, which was 4. Well, 24 divided by 6 is equal to 4. Then let's think about if we have 3 letters and we wanted to arrange them, how many different ways could we arrange them? Well, that goes back to our factorial notation, or permutation where we're just choosing every single one of the objects. That's going to be 3 times 2 times 1, which is equal to 6. So there might be a connection between this 6 and the fact that 3 factorial, or 3 ways to arrange the same letters, is equal to 6. So if we wanted to calculate the number of ways to choose 3 objects from 4 objects, but the order doesn't matter, we could have just divided 4 permute 3 divided by 3 factorial. In general, though, we would look at in choose R or in combination of R, but I like to say in choose R. We think of this as being, we can think of it as the permutation divided by the duplicates, which would be that R factorial. So, but if you think about it, in permu R is the same thing as in factorial divided by in minus R factorial. And then if we were to divide that by R factorial, that's the same thing as multiplying by the reciprocal, or 1 over R factorial. So that would show up right here. So this represents our permutation, and this represents the dividing by that R factorial to get rid of all the duplicates, because for a combination, the order doesn't matter. Okay, so in general, our in choose R formula is in factorial divided by in minus R factorial times R factorial. So what is the main difference between permutations and combinations? One, for permutations, order matters, and we have this formula for permutations. Combinations, order does not matter, so we get that dividing out of any duplicated arrangement, and so therefore we end up with this formula for combinations. In the next example, or in the next video, we're going to look at examples where you're going to pick, is this a combination or a permutation? And then we will work out a couple of examples.